All right, tonight what we're going to be talking about is an introduction to oil, or what we know as petroleum, and natural gas. So petroleum and natural gas are considered fossil fuels. What is a fossil fuel? A fossil fuel is something that came from a living thing a long, long, long time ago, and through processes, it became and turned into what we know as a fossil fuel. Fossil fuels are a form of chemical energy. Remember from the first semester, what is chemical energy? And actually third quarter, what is chemical energy? Well, chemical energy is energy that is stored. So as soon as you hear the word stored, little bells should be going off and being like, oh, stored. Yeah, that's the bigger thing of potential energy. Okay, so it is a form of potential energy in the bonds of molecules. Okay, and how do I either get energy from these bonds? Well, if I look at two little atoms, okay, and what happens is if I break this connection or this bond, it will release energy. Okay, and when I break or make bonds, we break or make these guys, you release or absorb more energy. So what happened would be then these guys would separate, okay? And by that process, we have either released or absorbed different amounts of energy. Okay, and the two primary ones that we're going to be talking about during this unit is petroleum and natural gas. These are the two types of chemical energy that or sources of chemical energy that we're going to be talking about. What is petroleum? Petroleum is an oil. Okay, that's what we talk about. Another term for petroleum is oil. And we've got natural gas. These two are so similar. Why? Because their origins were actually from the same exact thing. So these living things from a long, long time ago. That's where we got petroleum and natural gas. And therefore, they have a lot of similar characteristics. But the main characteristic actually is that they are made out of hydrocarbons. Okay, what is a hydrocarbon? Well, if you break down the word, it makes sense what it is. It is a combination of hydrogen and carbons. Okay, and so we've got petroleum, which is oil. It is made out of a hydrocarbon. We've got natural gas, which is made out of hydrocarbons. So if I ever see something like CH, any sort of combination of a CH, so carbon and a hydrogen, that is considered a hydrocarbon. What is the difference between petroleum and natural gas then? Well, it's really basically how many hydrocarbons you have, or how long the chain is what we say. So petroleum has more carbons and natural gas has less carbons. That's really the only difference of what makes something petroleum versus something making something natural gas. So why are fossil fuels considered to be non-renewable resources? If it comes from living things, hey, we have lots of living things. Why? And if they're going to be turning into oil and natural gas, why is it not considered renewable? Well, it's because it takes millions of years to replenish. So yes, it is being replenished, but it's at such a small rate compared to the usage. For us in our lifetime, it is considered non-renewable. So we will never get what the ratio of things that are dying and turning into oil and natural gas is not the same as the amount of usage that we're using. In fact, 80% of our energy comes from fossil fuels. 80%, think about that. 80% of every source of energy that we use is from a source of fossil fuels. So we use a lot of it. So what I want you guys to do right now is look at this graph. Okay, so what does this show? This shows the energy consumption in the United States from 1776 to 2015. So how much energy did we use, and where were the resources of where we used it? So if you look at it, originally in the 1770s to 1850, the only source of energy was biomass. Well, what is biomass? Biomass is trees. So obviously we're going to be burning using fire. We're going to be using a fire pit, things like that. That's our only resource of any source of energy, right? And then in 1850, we notice with the Industrial Revolution, we go with the coal. Okay, so that increases. But what else you should notice is that there's a huge source of energy spike right around here to right around here. And since about 1950, where is our main source of energy come from? Petroleum and natural gas, which these are the two fossil fuels that we will be talking about during this unit. Okay, so obviously we figured this thing out. We figure out that they're a great source of energy. So why do you think these fossil fuels have become such a great resource? And why do you think, guys, that this right here is such a big peak. What happened during the 1950s that changed everything? Well, one of them is that we had a huge increase in population. And whenever you have a huge increase in population, your demands are going to be larger. So if you have more people, you're going to need to use more energy. Another one is that we increased our usage of technology. What sort of technology did we increase? Well, if you guys look at it, we obviously use more uh, like computers, and we use more technology such as tablets, things like that. We also use a lot more cars. Okay. Before then, you would be more of a one car family, if that. A lot of times in the pre 1950s, you would even have a car. And then after the 1950s, you went to one car, and then we increased even more to 2 and 3 and 4 cars. So obviously, the increase in technology and the increase in demand has gone up, which means that the use of these guys will be going up. All right, so where are the fossils in fossil fuels? Well, they're not actually fossils nowadays. What happened is that oil is formed from oil and natural gas. Those are the same thing, actually. It's literally coming from the same thing, and whenever you find oil, you will always find natural gas right by, or whenever you find natural gas, you will always find oil. They are actually from the exact same thing, so they are always found right by each other. So oil was found from the remains of plants and animals. So you're talking about the ocean, okay? They were buried in the ocean floor, okay? So they died. A lot of sediment then fell on them. And then through the use of heat and pressure, obviously the pressure occurred because things kept layering on more and more and more, which increases your pressure. They turned into oil and natural gas. Okay, and so we have all these huge layers layering on top of, here's our dead animal, okay, and then we now have lots of sediments and lots of layers adding on and stuff like that, and so it increases the pressure, and what happens is that this churns into oil, okay, or natural gas. So now my fish is now oil and natural gas. But what happens is what earthquakes shift this. So now what happens is that these layers kind of break off, so the oil, which is a liquid, can then start floating up to the surface. Okay, which means that now we can see and we have access to this oil. If the earthquakes and stuff didn't happen and the earth didn't shift, then the oil would be permanently down underneath and we would never have access to it because there would be too many rocks and things on top of it for us to even have been exposed to it ever. So explain what briefly is happening. So it's kind of like what my really pathetic drawing on the previous page was talking about. But if you look at it, here's our ocean, here's our plant life, and what happens? Oh, they die, okay? And they go down to the bottom. All right. So here's where they died. And now what happens is that the sediment keeps piling up more and more and more, okay? And you notice that we've got more and more natural gas forming and oil right here. You can see that little blip right there. And what's happening is you add more and more pressure on and more sediment. These things become more and more like oil, and it kind of raises up, okay? And so these dead animals go down, they form the oils by more and more pressure, and then we have a pocket of oil on the bottom, and then you see the natural gas on top. It is always an order of oil because it has more hydrocarbons, more carbons, making it more dense. And then natural gas will always be on top of that. Why? Because they're made out of less carbon, so they are less dense. Okay, so how do we find oil and natural gas? First off, it's really important to note that you can find oil and natural gas on land and under oceans. Why? Because our land was an ocean at one time, or sea, and our oceans were oceans and seas at one time too. So therefore, the plants died and the animals died, and they kept having all these layers. So we'll find oil there. Okay, but how do you find it? First off, what you want to do is you want to find these hydrocarbons in a type of rock. So these geologists that are searching out for oil and natural gas, they're looking for these two specific properties of rock. First, it needs to be porous, which means that it needs to have openings in the rock. The second is that it needs to be permeable, which means that it needs to have a path to go from one place to another. Okay, this will allow the hydrocarbons to move from one pore to the other. So when we look at this little chart on the right, okay, these guys right here that I'm circling, these are considered pores. Okay, so when we look at this guy on the left, there are no holes, which means no pores. When you look at the middle guy, notice that we've got these little pores. Okay, so this is considered porous, but it says that it's not permeable. Well, what does permeable mean? Permeable means you can have a path flow from going one area to another. Okay, so here's my pores on the right-hand side. Notice I've got these lovely little pores, but it is also permeable because if I started as oil in this area, I could take a path all the way up here, I could take a path all the way up here, I could take a path all the way up here, which means that I am able to permeate through different layers, okay, which means that I could flow through it. So we want both it to be porous and permeable, not porous and non-permeable, and definitely not porous and non-permeable. So porous and permeable, two P's, that is what we are looking for to find oil and natural gas. Okay, so oil and natural gas are found in both land and underwater. Obviously, that's why we see these little oil drills, or not little, on land. A lot of times I see them down in central Illinois. You'll see these little oil rigs going in the middle of farm fields. And then another one is you'll see them outside on the ocean. If you've ever been to the Gulf of Mexico, you'll see these huge oil rigs out in the ocean. And what they're doing is they're drilling. And what they're drilling for is they're drilling for these through this porous and permeable stuff to try to get some oil. All right, so fill in the chart below and say if it's porous and permeable. So we've already seen this. So there's no pores, so this is non-porous. And this is also non-permeable. Why? Because there's permeable. Blah. Why? Because there's no path and there's no holes. Remember, porous means holes. Permeable means there's a path. Okay, so this guy, if I see these, this is porous. Porous. Why? Because it has holes. But this is non-permeable. And then last, I've got both it being porous, because it's got those holes, and then it also is permeable, because it's got a path. Okay, the next part on the note says, draw an arrow to a location that oil will be found. Well, we're looking for the pores, right? So we'd find pores, we'd find oil right here, 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 here. It is not permeable, which means that it is not the ideal, but it does have those pores, which means oil pockets will be found there. It's just not as easy to collect because it is not permeable. All right. Sedimentary traps. So since sedimentary rock is formed by the buildup of layers of sand and sediment, remember sand has they're just little tiny rocks, right? It often has more pores. Why? Because whenever you put circles together, which are these rocks, you will always have a little space where they don't mesh up, and so therefore you have a pore. There are two types of petroleum traps that we're going to be talking about. One is structural and one is stratigraphic. Okay, so what are the structural traps that we're going to be talking about? Structural traps are formed because of the deformation in the rock layer that contains the hydrocarbons. The two that you guys are going to have to know is a fault trap and your anticlines. Okay, fault traps, what the heck is that? Well, a fault trap is formed by the movement of a permeable and impermeable rock along a fault line. So it makes sense. This is where you see fault lines. So when we ask you to identify which one is a fault trap, look on here. Okay, here are your 4 different types. We're only going to be focusing on 3 of them. And where do you see a fault trap? Well, I see a fault line right here. So this would be my fault trap. Okay, and if we look at this on this right-hand side, okay, so here's my fault line. It says it's going to trap them. Okay, well, here's my gas. Here's my oil. Remember, oil is a liquid, gas is a gas. And so normally it would want to go to the surface, right? But what happens is that when it has a fault line, this is non-porous rock, so it kind of just stops it. It doesn't allow any of that gas or liquid to flow to the surface. So this is where it kind of collects right here. So this is a fault trap. Okay, that's one you're going to need. The anticline is an area where the strata has been pushed into a dome shape. These are extremely easy to identify. How? Because if you look at it, anticline starts with an A, and what does it look like? To me, it forms an A. Okay, so if you look at this, once again, if you look at your anticline, we've got this A type of shape, so therefore it is the anticline. This, you see a fault line, therefore it is a fault trap. Those are your 2 structural traps that you're going to have to be able to identify. All right, and then the stratigraphic trap is the other type. So we had structural and now we have stratigraphic. Stratigraphic traps are formed as a result of lateral and vertical variations in the texture, porosity, or lithology of the reservoir rock. So meaning the rock on top. So okay, so if I look at this guy, this is a stratigraphic. So I've got my natural gas, I've got my rock oil. So once again, your oil is always on the bottom, your natural gas always is on top, and it literally will always be oil, then natural gas. They are always found together. The source rock right here is where is your hard, this is basically your dead animals and plants. Okay, so this is the source of the dead animals or plants. Okay, that is being put under a lot of pressure. Once again, it takes a lot of time to go from a dead animal into this rock oil. So it's constantly still filling this up with the, that's your source rock. Okay, and then what happens with the stratigraphic, if you look at where your oil is found and where your natural gas is, why doesn't it rise to the top? Well, that's because this guy, the layer right above your oil and natural gas, if it doesn't rise to the top, is not permeable, meaning that we've got this gas, okay, and it cannot move past this layer because there is no pore or permeability, meaning it can't flow up to the surface. So that's why the stratigraphic ones occur. All right, so on this sheet, if you guys could please identify the different types of faults, or you'll be looking for your fault, you will be looking for your anticline, and you will be looking for your stratigraphic. So if we look at the first one, we've got an anticline. Once again, how do I figure that out? It forms this like nice looking A. Okay, the second one right here, what do I see right there? I see a fault line. Whoops. So this would be your fault. And then this one on the bottom is your stratigraphic. Why? Because this is your non-permeable stuff. Here's your source rock. And then it's being turned into oil and natural gas, but the gas can't go to the top because it is stopped because of the stratigraphic trap. All right. Hopefully you guys have a basic understanding of the introduction to oil and natural gas, and have a great evening.